All right, hello once again, Jeff Scott of Rankin Technical College. And as part of my never-ending quest to try to make life easier for my AWD1000 web development technologies and AWD1111 database-driven websites classes, I've been creating a series of video presentations based on the ebooks of Mr. Flavio Copes. I'm in my sixth set. So far, I've done HTML, CSS, JavaScript, ES5 to ESNext, and React. And I'm in the Node.js right now. And it's the longest one. It's got 189 pages in it. And I'm on page 111. Now, before we go into it, which is Async Await, as I've done previously, I'm going to go back and I'm going to take a look. And this is another free CodeCamp article. How to use Async Await in JavaScript with example.js code. All right. So it says in this tutorial, we're going to learn how to use Async Await, and beforehand, so this will be review, but we have already had lessons on event loops, callbacks, and promises, but let's take a look at that, and let's take a look at what they have in here before we jump into talking about Async Await. All right, event loops, again, are one of the most important aspects of JavaScript because JavaScript is single-threaded, meaning technically only one task can run at a time. It has a call stack, and all the code is executed inside of this call stack. Now, with the example they have here, you call first, which pushes that onto the stack. All right? And it says in the example above, you can see that we're logging two values in the console. When the first finishes execution, it is done what's called popped off the call stack, and the event loop will go down to the next line. So it sees this, and it basically does this, and then it pops it off, and then it goes and it does this. All right? So this is what you get for the result, and it's what you think you would get. It does first, and then it says final. So that's exactly what happens here. All right? So it says to understand things better, let's take a look at another example. Well, now notice that we've got first, and we've got final, all right, and we've got this set timeout. So what should happen if everything was run totally synchronously is it would say first, then it would say timed out, then it would say final. But that's not how things work. It says first, it comes in here and it says, oh, there's a timeout. So it throws it basically in a message queue, and it goes down and does the final. Then it comes back to here when that's been popped off, and it does the timeout. So I believe this would say first, final, timed out. And that's pretty much what they explain in here. I don't want to sit and read to you. There's what you have. All right. So how do callback functions work in JavaScript? Again, this is just some review. Callback functions are those functions that have been passed to another function as an argument. So again, the function here is getMovies. The callback is right here. All right. So you'll notice that what we're doing inside of the callback is we're calling getMovies. All right. And it's going to basically be, it's doing a for each here, so it's going to log out the title of both of these. So A New Hope and The Empire Strikes Back. So it says we have an array that contains a list of Star Wars movies and a function getMovies to get the list. It does what you think it would do. All right. But it says let's create another function called createMovie. It'll be used to add a new movie. So there's our original function. There's our getMovies. And there's our createMovie. Now, why does this matter? Well, the reason that it matters is it comes in here and it calls getMovies. And it says here to wait for 2 seconds. So basically it's going to say, oh, okay, I've got 2 seconds. I can throw you on the message queue and I can go down and do the next thing. So it's calling createMovies. All right, so we did getMovies already, but now it's doing createMovies. And it's adding a new one. But that also is going to wait for 2 seconds, and then it's going to push that onto the stack. So you'll notice that since we have a set timeout and another set timeout, that we've got the first two that print, And we're not printing, even though we call this create movies to have Return of the Jedi, it does not print in there. It says the problem here is we're not getting the third movie on the console. This is because create movies takes longer than get movies. The create movie function took 2 seconds, but the get movies took only 1 second. In other words, get movies runs before create movies is displayed. To solve this, we can use callbacks. All right. So it says here in create post, pass a function callback and call the function right after the new movie is pushed instead of waiting 2 seconds. So there is create movies right there. And you'll notice that as soon as it's done that, and it's called create movies, which pushes it back, all right, we're calling callback, which is basically the difference is it should come in here and it should throw this on a message queue, then go down and call create movies, add this, but don't call this until this callback that's here. Do not call that until it's been pushed on. So we should see all three, and we do. Hopefully that made at least a little bit of sense. So as it says here, now we get an updated list of movies. So how do promises work? Well, again, remember promises can be in one of 3 states. Pending, which means that it is not yet decided whether or not it worked, meaning it was fulfilled or resolved, or whether it didn't work, meaning it's been rejected. So it says, let's take a look. Promise takes 2 parameters, resolve and reject. When something goes wrong, reject is called. If you get all the way through and there was no problem, resolve is called. So we've got create movies down here, then get movies. This code isn't that different from what we saw before, except we're saying here, if there wasn't any error, resolve. And if there was an error, then reject. So if we get an error, it'll be something like error, something went wrong, and otherwise it'll resolve it. All right, once the promise is resolved, it calls for the then keyword and get movies. And if it doesn't work, you typically put some kind of a catch in there. All right. We've got a then. We don't have a catch in this case, but you typically would put one in. So finally, async and await. Async and await was designed because people said that although promises were better than callbacks, they still were difficult to use. So as it says, async is short for asynchronous. It allows a program to run a function without freezing the entire program, done using the async await keyword. Now, the key part of that, no pun intended, is you've got to put async before the name of the routine, all right? And whatever it is you want to have await will have an await in it. I don't see one in here, but typically that's what you have. So they're paired, in other words. All right? So the keyword async before a function makes the function return a promise always. And the keyword await is used inside of the function, which makes the program wait until the promise resolves. And there's our await right there. So the function execution, in essence, as it says, it pauses there and it resumes once the promise has been fulfilled. All right? With result becoming its result right there. So the code shows done in 2 seconds. So it says, let's look at a practice example here as we finish this up. All right. What is nice, the reason I picked this example, all right, is first of all, I like the stuff that Free Code Camp is pretty easy to understand. Plus, they've got a running example here, and they show it built in all 3 ways. In the above example, get movies is waiting for create movies to be executed in the async function. All right, so get movies is waiting for create movies, okay? And notice this init here is an async, and we've got the await on it. In other words, create movies is asynchronous, so get movies will only run after create movies is done. All right. Okay, I think that's enough to get us started at least. So let's jump back into here and take a look. So async await, discover the modern approach to asynchronous functions in JavaScript. JavaScript evolved in a very short time from callbacks to promises. Since ES 2017, asynchronous JavaScript is even simpler with the async await syntax. We get an intro, talk about why it was introduced, how it works, another example, promise, code is simpler to read, multiple async functions, and easier debugging. All right. So, as mentioned there, JavaScript evolved in a very short time from callbacks, which was in ES5, to ES 2015 to ES 2017. So it's gone from callbacks to promises to async await, and you'll still see all of them used. Now, I would say that probably the majority of what you see in new code development, of course, would be async await. But there's still a lot of legacy code out there that uses just straight callbacks and or uses promises. That's probably not going to go away for a long time. Async functions are a combination of promises and generators. They are a higher level of abstraction over promises. As it says, you have to understand promises because under the hood, that's pretty much still is what's happening here. Why were they introduced? They reduced the boilerplate around promises and the don't break the chain limitation of chaining promises. As it says, when promises were introduced, they were meant to solve the callback hell type of problem that we talked about earlier. They were good primitives around which a better syntax, could be done. But they were meant, I think at least, to be kind of transitional in that they weren't meant to be a final product. They were meant to be something on our way to a more final product. All right. They led us to the land of async functions. So an async function returns a promise as shown in the example here. When you call this function, you append await, and the calling code will stop until the promise has either been resolved or it's been rejected. And the function must be defined as async. So you need await and async. So it says this is a simple example of async await used to run a function asynchronously. So we look down here. What do we have? Console.log. So we're going to put the word before. Then we call do something. All right. Again, we've got a timeout here that says I did something. And then we've got this do something right here. All right. So we're calling do something here. All right. And notice equals async, and there's the await, and it's going to call do something async in here. So this is going to say do the before. It's going to wait here for 3 seconds, so it's going to do the after, and then it's going to do I did something after the 3 seconds. All right. Now you might look at that and again say, well, I don't understand. You had something before and it worked. The idea is the more complex your code gets, usually the less code that you have to put in. You put in less with async await. You also put in less than you would if you used promises. In promises, you put in less than if you used callbacks. All right. Prepending the async keyword to any function means that function will return a promise. Even if it's not doing so explicitly, meaning you don't put it in there, it will internally return one. And as it says, That's why this code is valid, and it's the same as this code right here. So this is just returning test. This is returning promise, but they're both basically doing the same thing. So why do you do this? Again, the code is typically simpler to read. It says compare that with using plain promises with chaining. All right, so it says here's how you'd get a JSON resource, because anywhere over here, this can break. All right, so you do this. If it works, then you do this, etc. With async await, it may or may not look like there's a lot of difference, but if for no other reason, you're kind of breaking this up into components, which makes it easier to use. Async functions can be chained very easily, and the syntax typically will be easier to read than with promises. And one reason is, yeah, you're chaining them, but each one of these is in their own function, as opposed to when you chain promises with dot then, etc. It also provides, going along with the last thing we just looked at, for easier debugging. And the reason for the easier debugging is because since you're breaking things up into individual routines, if you've got a problem, you know right in which routine to go in to try to fix it. All right. I think we're going to stop right here, and I will pick it up in the next lecture, and we'll start getting into the node event emitter.